Chapter 10, number 53. One way to store energy is in the rotational motion of a flywheel, and some have proposed using such technology to power automobiles. One unit is based on a 6 kilogram flywheel in the shape of a hoop of radius 1/10 of a meter that spins as fast as 60,000 RPM. A. How much kinetic energy is stored by the flywheel when it's rotating at its maximum rate? And B. If the vehicle requires an average power of 11 kilowatts under normal driving conditions, for how much time can it operate with the energy stored in this flywheel? So we go back here and we say, well, A is relatively easy. The kinetic energy will just be 1/2 I omega square, and I will be mr squared because it's a hoop. And so we're left with 1/2 times 6.0 kilograms times 0.10 meters squared times 60,000 RPM, which is rev per minute. And that's kind of annoying because I want to have in SI standard units, and that's neither of them. So the first thing is remember that there are 2 pi radians per rev. And the next thing is remember that there, of course, is 1 minute per 60 seconds. And then we have to close this and square it. So a lot of grungy typing, but we just put in a calculator. We get 1,184,352 joules, which with sig figs becomes 1.2 times 10 to the 6 joules, or as your book says, 1.2 megajoules. And then part B is relatively easy. The power is the work over the time, so we can reverse this and say the time is the work over the power, so it's 1.2 times 10 to the 6 joules over 11,000 joules per second, which is what a watt is, and we end up with 107.67 seconds, which becomes 108 seconds, which your book tells you is 1.8 minutes. 1.8 minutes. So there we go.